Hi all, in this video I'll be guiding you through the subtopic 4.4 reactions of organic compounds. Right, to begin with, this subtopic has got 4 parts, which are, the first would be types of bond cleavage. Now bond cleavage here means we are referring to bond breaking, and this bond breaking will happen during reactant turning into products. Second, we will be looking into types of intermediates. Third, we will be looking into types of reagents and reaction sites. And finally, we will be looking into types of reaction. Jadi, this will be a long video, so not so long. I hope to make it not longer than 30 minutes, but feel free to pause whenever we are moving from one part to another part. All right, so let's get started. So with the first part, now let's look into bond cleavage. So what is bond cleavage? As I told you, it is about bond breaking. So kenapa perlu bond breaking ni? Because when a reactant wants to change into product, okay, the reactant bonds must undergo breaking and they rearrange to become product. So in products, bond making happens, okay, or bond forming happens, right? So in this bond breaking, we have two types of bond breaking, which is homolytic cleavage and also heterolytic cleavage. All right, so what is this homo and hetero? Right, let's look at homolytic cleavage. So homolytic cleavage, first thing that you need to know, it happens in a non-polar bond. What is non-polar? We know that a non-polar bond exists between two atoms of similar electronegativity. And here the bond will break symmetrically. Okay, so when it breaks symmetrically, that means it will break into two equal parts. So one atom will have one pair of electron. Why do I say one atom will have one pair of electron? Sebab kita tahu satu bond, untuk menghasilkan satu bond, kita ada dua electron. So bila dia break secara homolytic, that means break evenly. Let's say I've got atom A and atom B. One of the electrons will be given to each, okay, each atom. Now I want you to take note of the arrow I'm using over here. In chemistry, arrow ada maksud. When I draw a double-headed arrow, okay, so like this, that means that is two electron moving. So when I'm drawing a single-headed arrow, that means one electron is moving, which is true for this case lah. Sebab dalam homolytic cleavage, when we break a single bond homolytically, one electron is traveling. Okay, and please remember, you have to draw your arrows satu atas, satu bawah macam ni. Because semester 1, we have learned that, okay, electrons have got two spin up and spin down. So we have to show that also during the movement of electron. So one different spin electron is moving towards B and a different spin electron is moving towards A. All right. So what is the hasil from homolytic cleavage? It is called a free radical. So how does a free radical look like? Let's look at this example over here. So as you can see over here, we have this XX bond. Okay, so I would draw it as X, single bond X. Now, this is a non-polar bond, jadi it will break homolytically. So how do you draw it? You draw it like this. So once you have drawn it like this, what is your result? You will get free radicals. So berapa free radicals? Dua lah in this case. So I can put a 2 in front there, no problem. Okay, and this homolytic cleavage needs energy. Dia tak boleh berlaku sewenang-wenangnya, just like that. You have to supply it with energy, and that energy is in the form of UV. This is the experiment. This will be a part of the experiment 4. Okay, you will learn more about this during experiment 4. Right. Next type of cleavage is heterolytic cleavage. So heterolytic cleavage ni happens in polar bonds whereby your atoms have different electronegativities. So the single bond now breaks unsymmetrically. Okay, it doesn't break symmetrically, it breaks unsymmetrically. And where does the electron go? The electrons are now given to the more electronegative atom. So when it's given to the more electronegative atom, so that atom will have more electron gun. So it becomes an anion. So the atom with less electron becomes your cation. Okay, so let's look at an example. So as you can see here, in this situation, A is more electronegative than B. Thus, it will attract all the electrons from the single bond towards itself. As you can see here, I am using a double-headed arrow sebab dua electron akan travel towards A since it is more electronegative, and as a result, I have A an ion and B yang ada kurang electron will be B cation. What happens if B is more electronegative? You can see over here, all the electrons from the single bond will be given to B, and then what we have B becoming the anion and A is now the cation. I hope you can see it clearly lah. All right, so this is the end of part 1, okay, which is types of bond breaking. Now we are going to go to part 2, okay, types of reaction intermediates. So reaction intermediate ni ada 3 jenis, okay. Free radical kita dah lihat sebelum ni, this term. Now carbocation, carb and ion. So this is basically referring to cation and anion juga. Tetapi since we are learning about carbon compounds, we will be seeing species carbon yang ada positive charge and species carbon yang ada negative charge. So we add carbo in front of it. Carb and carbo lah. Alright. So what is one important property you have to know about reaction intermediates? Intermediates, I think you understand the word intermediates. Intermediates adalah bahan perantaraan. Okay, the middle species lah, in between a reactant and a product. Okay, before a reactant can change into product, it must experience intermediate species, then you have conversion towards product lah. All right, so these are highly unstable and highly reactive. Now if you remember some of your thermochemistry or activation energy, okay, all these things, your energy profile diagram, sorry, we have reactant, we have product here. So atas bukit ni is where intermediates live. Okay, this is where intermediates will be lah. Same goes to whether it's an exothermic or an endothermic experiment, where the turning point between reactants and products, that's where intermediates usually live, and they are very highly reactive and unstable. Right, next. So carbocation, conclusion dia adalah positive charge on carbon atom. We form this, remember, cations and anions we can only form through heterolytic cleavage. So contoh, we have it over here. This is the explanation for this contoh. As you can see, carbon is attached with a very electronegative atom, which is chlorine. So chlorine is more electronegative than carbon. So CCl bond is a polar bond. So what happens when CCl bond is a polar bond? We have heterolytic bond cleavage di mana chlorine, which is more electronegative, akan tarik semua elektron ke arah dia, and then forming an ion, leaving behind a carbocation. Okay, so that's the story of carbocation. What about carb anion? Carb anion simply means that the negative charge is on carbon atom. Again, we form it through heterolytic cleavage. So example, okay, in this case over here, we have carbon attached together with a metal. Lithium. Lithium, we know it is from group 1. So group 1, and we know it is less electronegative. So less electronegative meaning, in this case, carbon will be more electronegative than lithium. Thus, carbon now will attract all the electron towards itself, forming a carb anion, and the lithium now remains as a cation. Okay, so I think it's quite clear what is a carbocation and carb anion. Next, for free radical we have already seen free radical is formed when you have homolytic cleavage. So bila free radical form, as you can see over here, in this case, please take note the arrow. Okay, so arrow dia kena jelas, and I don't want the arrow hanging like this. Suka hati awak nak lukis macam ni, tak nak Please don't do that. Okay, I want the arrow to be very specific. From the bond, okay, as you can see over here, from the bond to the atom. I want it to be very, very specific. Okay, so we have free radicals over here. Same goes to this. Okay, if I supply it with energy, UV, this single bond within carbon-carbon may undergo homolytic cleavage. Okay, so please correct the arrows, make it more visible in your notes. Okay, please do this. Right. Done with part 2. Sorry, not done yet. We have to look into stabilities. Okay, we are not done with part 2, so sorry. So, stabilities of these carbocations, carb anions, and free radicals. So, 4.1, we have talked about primary, secondary, and also tertiary. Now, these carbocations and carb anions also can be divided into primary, secondary, and tertiary. Now, before we go into primary, secondary, tertiary, I want to introduce a group to you. Okay, this group is known as alkyl group. So, what is this alkyl group? Okay, alkyl group sebenarnya awak dah tahu dah. Alkyl groups, you have learned it in SPM. So, example of alkyl groups, okay, which are known as alkyl group, is your CH3 branch. Your CH2, maybe I write it as C2H5. Okay, and C3H7. So all these are your alkyl groups. Their names: methyl, ethyl, propyl. These are all examples of your alkyl groups. Okay, we give them a general symbol which is R. All right. So R ni, what is the property of R? R are electron donating groups. So please remember this. Please start remembering from today sebab kita akan guna istilah EDG ni for upcoming chapters also. EDG. So R groups or alkyl groups are electron donating groups. Okay, so that means they are very helpful to stabilize positive charge. Obviously, kalau ada positive charge, maksudnya dia kurang elektron kan. Jadi, bila kita ada EDG, dia akan stabilize the positive charge on a carbocation. So, overall conclusion is that bila ada lebih banyak R group, so as you can see, when you increase the number of alkyl group, stability of carbocation increases. Okay, so let's look at an example over here. So this is an example whereby, as you can see, this is primary. Why do they call it primary? Sebab dia ada satu R group. We call this secondary sebab dia ada dua R group. We call this tertiary sebab dia ada tiga R group. And for carbocation, tertiary paling stabil, most stable. And this will be least stable. Okay, right. So now, do we have a specific example? Let me show a specific example. So let's say I have got CH3H carbocation, and here I have got CH3H carbocation, and here I have got a CH3, CH3, CH3 carbocation. So as you can see over here, I will highlight again, this is a primary carbocation sebab dia mempunyai satu R group sahaja. Whereas the next one is a secondary carbocation because it has got two R groups. And the third, we have got three R groups. Now, methyl group or methyl group is an example of R group. Okay, alkyl groups, as you can see here, saya dah beritahu. These are some examples of R groups. So, when the R group increases, in this case, methyl group increases, the stability of the carbocation also increases. Next, what about carb and ion? I think by now you can guess that the trend will be opposite. Okay, because carb and ions are already negatively charged. Kalau kita supplykan dia dengan lebih banyak EDG, dia suka tak? Nope. Okay, so more EDG is not favorable. So as you can see over here, alkyl groups, which are electron donating groups, destabilize, okay, the negative charge on carb and ions, whereas halogens can stabilize the negative charge on carb and ions. So this part over here, okay, we leave it for future. Okay, we leave it for okay, we leave it we leave it for future chapter, okay, regarding a halogen. For now, you focus only on alkyl group. So alkyl groups will destabilize carb and ions. So less number of alkyl groups, okay, stability of carb and ion increases. All right. So halogen ni we leave it for the next further chapters. Future chapters lah. Okay. So here we have an example. I think it's quite clear now. The methyl. Okay. The methyl with no alkyl group is the most stable carb and ion. So in this case, this is the most stable. This is the least stable. Kalau dia carb and ion, tertiary adalah least stable. Okay, least stable. Alright. Free radical pula. Can you guess? Is it going to follow carbocations pattern or carb and ions pattern? Now, free radical. So, for example, we have chlorine free radical. Now, this situation here is a less electron situation. It has got less electrons sebab tak ada kawan tu. Okay, only got one electron over there. Therefore, when you have a less electron situation, it will follow like carbocation pattern. Okay, whereby the stability of the free radical increases with more alkyl groups attached. So, as you can see, tertiary free radical is the most stable, followed by, okay, followed by secondary and then primary, because free radicals here indicate the center, the carbon has less electrons. All right, so with this, we have finished two parts. So if you want to pause the video, you can pause the video and then read by yourself and come back towards the part 3. Okay, so let's look at part 3 now. Okay, so this is part 3. So for part 3, we have got some new terms over here which refers to the reagents. So what are these terms? Electrophile and nucleophile. Okay, so let's look at it one by one. Electrophile. I think you all understand the word file now. So file means like, right? So electrophile, that means it likes electrons. Okay, so in order for you to like electron, that means you must be electron deficient species. What is the meaning of deficient? Deficient means kurang lah. Kurang species, kurang electron. Electron deficient species. Okay, and then you are ready to accept electron. So that makes you an electrophile. So electrophiles here can be neutral or can be positively charged. Neutral meaning we can remember back our Babal, which are incomplete. Okay, incomplete octet species because they have space to receive more electrons. Okay, so neutral also can mean those who have empty d orbitals. So these species are all ready to accept electrons, right? Because they have the space, therefore they are electrophiles. So we have some examples of electrophiles over here. As I told you, cations are definitely electrophiles sebab memang dia kekurangan electron. And then some Lewis acids, we call them as Lewis acids. As you can see, ada species Babal dan ada species yang ada empty 3D orbital dan also oxidizing agents. These fellas are also electrophiles. Okay, we call them electrophiles. Now okay, let's keep this first. Let's go to nucleophiles. Okay, nucleophiles meaning nucleus loving lah. Kalau direct translation dia adalah nucleus loving. Now, sorry, that's a wrong spelling over there. Nucleus. Okay, right. So that's nucleus loving. So nucleus loving indirectly means there's proton in the nucleus, right? So it's like proton loving, aka positive loving. Okay, so positive loving. Who likes positive electron rich species which are lacking in positivity? Likes the nucleus lah, and we call them as nucleophiles. Okay, we can also call them as electron density low species lah. The molecule has got low electron density. And what kind of species they can be? They can be neutral or negatively charged. So when I say neutral over here, you can see species with lone pairs. Those are examples of nucleophiles. Okay, so lone pair kan, there is like excess electron. So it is electron rich. All right. And there can be electron pair donors. So when you have lone pairs, you can become electron pair donors. I think we have learned this under dative bond formation. Next, let's look at some examples. As I told you, anions and carb anions, memang kita tahulah dia adalah nucleophile, and Lewis bases. Why do these two species shown? Because these are clear examples of species with lone pairs. Okay, so I think you can understand now what is an electrophile and nucleophile. Okay, nucleophiles is plural, electrophiles are plural. Now we are going to look into some sites atau lokasi-lokasi on a compound. Sebab when the reaction is happening, not all the time we have individual species like this. Sometimes the reaction happens on a molecule. So we have to examine a molecule. So let's look at electrophilic site. So what does that mean? Electrophilic site means the lokasi yang mempunyai low density of electron. Okay, so the lokasi is low, that has low density of electron. That's why it likes electron lah. Okay, so electrophilic means it likes electron. Please remember. So itself must have low electron. Jadi, if we are talking about sites, lokasi, that means that region tu ada low electron density. Di manakah region-region yang ada low electron density? In this case, as you can see, when it's attached to a more electronegative atom. So when the carbon is attached to a more electronegative atom, it becomes partially positive. So when it becomes partially positive, all this arrow that I'm drawing is now your electrophilic site. Maksudnya lokasi electrophilic. Why do we call it lokasi? Because this is a part of a molecule. For example, dalam haloalkane, maybe a long haloalkane over here, this is a part of a molecule. Maybe bahagian ni dia bukan polar pun. Okay? So only this part, so it becomes a part of a molecule, so we call it as an electrophilic site. Same goes to this alcohol. For example, if let's say I have got propanol. Okay, so if I'm having propanol, you can see that the carbon CH2 and CH3 I'm drawing, that carbon are neutral, nothing, no electron density changes or anything to that carbon, right? But whereas the carbon which is attached to oxygen, okay, will experience low electron density. Okay, the region of low electron density. Thus, that becomes the electrophilic site because it's a part of a molecule. Okay, dia bukanlah satu molecule like this. Okay, dia bukanlah satu molecule like this. We can say, okay, this is an electrophile. No, it's a part of a molecule, so it becomes an electrophilic site. Now let's look at nucleophilic site. So nucleophilic sites will be the opposite of electrophilic sites, where you can guess it will be high electron density region lah. Where is high electron density region? Between double bonds, between triple bonds, and inside a benzene ring. These are all high electron density regions. Obviously kan, sebab pada lokasi yang sebenarnya kena ada 2 elektron, kita pergi sumbat lagi 2 untuk menghasilkan double bond. So this region is very concentrated with electrons. So it becomes a high electron density region. So high electron density region means it wants to look for some positivity. So when it wants to look for some positivity, we say this region is a nucleophilic site because it is on a molecule. It's a location on a molecule. For example, let's take 1 butene or maybe 1 propene. Okay, so 1 propene might look like this. I've got CH2, 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 and a CH3. So only this part, as you can see, has high electron density, kan? So this is a location on a molecule, so we refer this to a nucleophilic site. All right, so I hope that helps. Okay, we are done with part 3. Lewis acid is just example of your electrophilic species, and Lewis base is an example of nucleophilic base species. Okay, you can just read that, no problem. I've already talked about it when we are talking about nucleophiles and electrophiles. Now we are going to go into part 4, the last part, which is type of organic reactions. So we have, in general, we have 4 types of organic reactions. We have moles, oxidation, and so on. But we're just going to focus on these 4 general words. When we go into each chapter in detail, I will describe each organic reaction in detail, like what exactly is happening. For now, just kenal sahaja. What is addition, what is substitution, elimination, and arrangement. So this is going to be very quick. So addition means what? We are going to add groups of atoms to adjacent atoms to form a multiple bond. So we have 2 types of specific addition. We have electrophilic addition and nucleophilic addition. So electrophilic addition, just kenal saja, happens for alkenes. I want you to take note, start learning alkenes, because next chapter we are going to do alkenes, alkanes. So electrophilic addition happens to alkenes. Okay, whereas nucleophilic addition happens to carbonyl compounds. So carbonyl compounds, we have got 2. We have got aldehydes and ketone. So kenal ni. Why do you need to kenal? Because your assignment, sometimes you might be seeing these reactions there. So you have to label them and give some explanation. Okay. Next, we have substitution reaction. What do we understand about substitution? I think football game also has got the term substitution, means penggantian, replacing it. And there is 3 types of substitution: free radical substitution, nucleophilic substitution, and also electrophilic substitution. So free radical substitution happens when you have alkane or alkyl groups. Okay, so that's free radical substitution. Electrophilic aromatic substitution happens to benzene or the aromatic family. And then nucleophilic substitution happens, in this case, happens for haloalkanes. All right. So just kenal, what are the type of reactions? So as you can see, for nucleophilic substitution for haloalkanes, the OH, which is the nucleophile, menggantikan the bromine to become alcohol. So we will look into these reactions deeper when we go to chapter 7. Next, we have elimination. What do we understand about elimination? Elimination means we have to remove something. So a good example is from your Form 5, whereby we have alcohol turning into alkene. All right. So we also have some elimination during polymerization. So polymerization, condensation polymerization, if you remember. Okay, condensation polymerization is actually a result of addition plus elimination. Okay, but a perfect example would be this lah, alcohol turning into alkene, an easy one. And finally, we have got rearrangement. So rearrangement, you can already guess that it would involve change in atom position. So occurs when a single reactant reorganizes the bonds and atoms. Okay, this example here is a high-level example, but in your syllabus, we will be looking at rearrangements of carbocations. Okay, because kita dah tahu dah stability of carbocation, so sometimes we are given primary carbocation, dia akan rearrange untuk jadi tertiary. Why? Because want to improve stability. Alright, so and that's all for this subtopic. Okay, so hope you can go through this subtopic, then we will quickly answer some tutorial questions. I think you can start doing some tutorial questions. Question number 15, the last 2 questions, which would be 17 and 18. Try practicing them, then I'll see you in class. All right, thank you.